much more carefully.
Well, don't change
Can we get
anything
darker?
if I'm going to be pleasantly surprised.
Well,
I think he was lying. I wasn't pleasant.
Unpleasant is what I meant.
Change
You may have been
anything.
unpleasantly surprised. So, you know, if you've done some of these and then I make them non-mandatory and you've gone ahead and done them, then they'll be made as extra credit. You know, it's not fair to just, you know, nuke you. So 3.1 is not too bad, right? Write a program that accepts the lengths of three sides of a triangle and then print the triangle is equilateral or the triangle is not equilateral. Yeah, that's not too bad. Let's take another look.
3.2 is when it started getting hard. Like, I remember 3.1 easy, but then I got to 3.2 and I was like, dang.
Yeah, it's like,
They amped it up real quick.
right.
3 was the one I was having trouble, so I stopped.
Now, my goal was not for the mind tap exercises to be more difficult than my own exercises. You know, I don't mind if my own exercises are difficult because, you know, then you can ask me questions about them and stuff like that. But let's take a quick peek at 3.2. Some of these I'm just going to make homework assignments, but I'm going to write them up. One of them I became flat out convinced that they have the wrong formula in there and that there's no way you can get it right. Okay, I guess I've already looked at that one. Why is that one that? What's the difference between 3.1 and 3.2? Accepts the lengths of three sides. The program should output whether or not it is a right triangle. How do you know if something is a right triangle? The square of one side equals the sum of the squares of the other. So that one's a little bit interesting because you'll have to have several if statements to get it to work. What would that look like? You know, you're going to ask the user for three sides of a triangle. You know, input A, input B. This is not valid code, right? Input C. And then you know it's a right triangle if one value squared is equal to the sum of the squares of the others. So it's going to be like three different if statements or one great big if statement. Go ahead and why don't we do this one together? You don't have to type it in as I'm typing it, but here's the way I'm going to make it work is I'm going to set a right variable equal to false, and then I'm going to have some if statements, and if any of them match, then we're going to set right equal to true. So like if a to the power of 2 is equal to b to the power of 2 plus c to the power of 2, then it is a right triangle, right? Right is equal to true. And then we're just going to have two other versions. If b squared is equal to c squared plus a squared, and then if c squared is equal to, you know, a squared plus b squared. Okay, so I went to 3.2. If, wait, we have to ask them for this stuff first. I'm just going to cheat, copy and paste that. So first, I'm just going to call it A, B, and C. A is equal to input of that. Int or double, doesn't much matter. Double input, quote, all of that, plus a space. There we go. I'm going to do the same thing for B and C, except change the messages up. So I'm just going to copy and paste that. You know how I like to do. Highlight an entire line. You move your cursor to the top and hit Shift down cursor. And then so this needs to be the second side and the third side. Yes, sir.
Can you just remind me what double does?
What am I doing? Oh, yeah. Sorry, I started to space out there. I panicked and thought I was teaching you Java. There's two kinds of numbers. There are whole numbers, and then there are numbers of decimal places called floating point numbers.
Yeah.
Double, yeah, I am spacing out on you. Thank you for asking that. That was ignorant. I just got out of a class in which double is the correct keyword.
Oh, okay. Well, there it is.
There we go. Yeah, okay. I'm teaching Java and C# at the same time. Hope you're happy about that. Nah, float. Thank you. You earned the brownie points today.
The no prize.
Get the prize. All right. And so, is the triangle a right? Well, let's find out. That should be A equals float input enter first. B is equal to float input second. And C is equal to float enter the third. And then if A to the power of 2 is equal to the B power 2 plus C to the power of 2, colon. I'm going to set a variable equal to false, and then any of these if expressions are going to set it to true. So, right equals false, capital F. Slight difference between this language and C, C++, Java, etc., where you don't capitalize it. So if A star star 2 equals B star star 2, by the way, if you just walked in, we're working on programming exercise 3.2. If that's true, then right equals capital T true. If B star star 2 equals A star star 2 plus C star star 2. And like I just said, you walked in late, we're working on exercise 3.2. Then right is true. If C star star 2 equals A star star 2, whoops, where'd that come from? A star star 2 plus B star star 2, colon. Then right equals true. Otherwise, right is equal to false, but we've already covered that up there. But we could throw it in anyways, just be super picky about it. Else, colon, right equals false. And like I said, that's not strictly necessary because we've already initialized right to false up there. And then we just have an if statement. So we're going to make it say the triangle is a right triangle, if that's true, right? So if right, you might like writing it like this, if right equals quote true, but that's actually superfluous. It's kind of redundant. You can just leave off the equals true. I think I'll leave it there for now, but I want you to tuck it away in your head that if you're comparing something equal to true, you can just delete the equal true part. In that case, we're going to print our message. The triangle is a right triangle. Print, parentheses, quote, the triangle is a right triangle. Period. End quote, in parentheses. Back tab. Else, colon, print, parentheses, quote, the triangle is not a right triangle. Period. End quote, in parentheses. Well, let's run it and see if I have any syntax errors, which is likely. Into the first side. 3, 4, and 5 does make a right triangle. So 3, 4, 5, the triangle is a right triangle. That seemed to work. Let's run it again with some invalid input. If they're all the same, it's an equilateral triangle, which is not a right triangle. 3, 3, and 3, it is not a right triangle. All right, I'm going to test it out, or I'm going to try to see if it's worthy of submitting. So I'm going to click on the task list here. Do run checks. And pray that it works. All right, it says that it ran the check and that it worked. If we want to see what it checked with, I could click on this little right arrow here. 9 out of 9 checks passed. It tried 3, 4, and 5. It tried 3, 5, and 4. Right? It tried 5, 4, and 3. It tried a whole bunch of different ones. And hopefully it eventually got some that were not correct. Like 5, 2, and 2 should not be a right triangle. All right. If you didn't get to type all this in because you came in a little late, I am going to put it in the notes. Okay. So we've done that one. I'm going to take a look at 3.3 now. Well, I guess I'm going to pause and make sure everybody else who's, at least came in here, it's at the on time, has it working. So you can do it in one if statement, which is totally cool. What would that look like? If A star star 2 equals B star star 2 plus C star star 2, or, and then hook up another one, right? If B star star 2 equals C star star 2 plus A star star 2, and then tack on one more. Or C star star 2 equals A star star 2 plus B star star 2. Does the exact same thing. And we don't have to put it all on one line. We could do it like that, I believe. You might have to do something special, like put some backslashes or something at the end. Do you have to put in some special syntax to get your long or to work? Or? Okay.
All right. I don't even have to tab it.
All right, that's cool. Anyways, that'll work. And that's more, it's a little bit cleaner, right? Not setting a variable equal to false and then setting it equal to true, right? This is nice and clean. Probably a superior solution. This is known as setting a flag. If it is a right triangle, we set a flag, and then we use that flag to run the print statement. So putting it into idle, you don't have to do this. I just want to make sure it works. Print right on. Okay. Are we on lecture I? I believe we're on I. Okay. Invalid syntax. Okay, that did not work. How do you get it to?
I didn't put tabs on B and C. It's just.
There's a way to get this to work. Yeah, if you.
Well,
that should work.
I don't know if it's on main line or
Nah. What is it? Java. No, Python. Still have Java in the brain. Python line continuation character. Backslash, a single backslash will do it. Okay, if you want to tab it out like I had it because you think it's pretty. Apparently you don't have to do this on the online editor.
Well, I think it may just be because it just moved it over. So it's on one line, but because it's compressed.
Yeah. Okay. So that'll work. You can use a single backslash to mean I want this statement to span more than one line. You're not going to want to do that very often, but if it makes it look cleaner, feel free. Like you could do this, if backslash A equals, backslash B colon, print, yay. Whatever. That looks ridiculous, right? You wouldn't do that. But if your if statement is getting really nasty and complex, then you're allowed to break it up into multiple lines if you use the backslash. This is the line continuation character. Let's make sure that works. 3, 4, 5. Yep, that works. So this is a superior solution. Thank you for pointing it out. I don't know why I avoided doing it to begin with.
Yeah, in my opinion, I had no clue what to do. I sat there for like an hour and I was just like, I don't understand like how I'm supposed to like degrade the values as it continues to bounce. Makes no sense to me.
The bouncing ball one, I became convinced they have their math wrong, and there's no way to ever get credit for it. So that's one that I'm going to move to actually be an assignment that I give you. And then, okay. Yeah, 3.3 was challenging. Modify the guessing game program so that the user thinks of a number that the computer must guess. No, this one's actually not so bad. This one's not actually as bad as what they ask you to do in a minute, which is to where... this is the bad one. The computer must make no more... Yeah, this is the unpleasant surprise. I don't consider the triangle ones too difficult, even if you had trouble with it, no shame. But I don't consider, this one I had to bang my head against to get it to work. And if your prof's having to bang their head... Anyways, awesome if you got it working. You have my respect. The computer must make no more than the minimum number of guesses, and it must prevent the user from cheating or entering misleading hints. Now, as far as I could tell, this is a misleading statement because it never checks that. Just flat out never checks that. Never checks for the minimum number of guesses. And so the way they want the program to work is you're going to enter a minimum number and a maximum number, and then the computer is going to guess. The computer makes a guess, and you tell it whether that guess is too large, too small, or right. And if it's too large, it sets its field appropriately, right? It thought the number was supposed to be between 0 and 75, and so it guessed 50. And you say, yo, that's too large. Then it knows, oh, the number has to be between 0 and 49. So it adjusts its range appropriately.
Wouldn't that be considered cheating?
No, it's cheating when you start lying to it about whether it's too large or too small. If you get to the point where you've given it misleading information, like you say 87 is too large, and then you say 86 is too small, well, what's it supposed to guess, right? 86.5? No, they're supposed to be whole numbers, and so that's cheating, and that's when it yells at you. So I'm going to come back to the idea of that one. I've already got the answer here, and that's not going to help us if I just scroll up and down through it. So I'm going to remove 3.3. I may remove an awful lot of these from the mandatory list and make them extra credit. But the next one and the one after that, I actually want to make our homework assignments when we're ready for them.
Oh wait, that was 3-3. 3-4 is the bouncing ball, isn't it?
3-5 is the bouncing ball.
Oh, okay.
Yep. 3-4 is the population, and that one had... No, you're right.
No, 3-5 is the population.
3-5 is the population? Okay. So yeah, here's the way it's supposed to work. A standard science experiment is to drop a ball, see how high it bounces. Once the bounciness of the ball has been determined, it gives a bounciness ratio. So you take your super ball, you drop it from a height of 10 feet. And then if it bounces 8 feet, 8 divided by 10 is 0.8. That's its bounciness index. So their example is if you drop it from a height of 10 feet and it bounces 6 feet, its bounce ratio is 0.6. And so if you're trying to figure out how far it'll keep bouncing, then you add the 10 to the 6, and then you take 0.6 of that bounce and get 3.6. Here's the mystery.
Yeah.
They tack in another 6 feet there. It's not a bouncing ball does not mysteriously suddenly bounce the same height between the second and the third bounces and then start decreasing again.
Well, I thought they meant like that they're gonna have to use that in the distance traveled, because if it bounces up 6 feet, then it has to travel down 6 feet before it bounces again. That's what I thought.
Well, yeah, I could dig that, but then they don't show that for that, right? I mean, each one would be doubled.
Yeah.
It's
It doesn't. It's hard. At least for
Did
me.
you ever get it to work? Did anybody get it to accept your answers? No. I think whatever equation they're following here is incorrect. And since I can't figure out the logic of doubling up on this like that, I was never able to get it to pass any of their quizzes.
But wouldn't it lose inertia?
It would. That's what it's trying to do, and that's why I say that's wrong. Right? It's not going to bounce 10 feet the first time, 6 the second, 6 the third, and 3.6 the fourth. One of these should not be there.
Yeah.
Probably not. Maybe they meant to put like a negative 0.6. Because if it's a negative 0.6, then
Yeah, it should be 0.6. There would be one more if it bounced a fourth time. It would be 0.6. And then it would be 0.6 times 0.6, you know, 0.3, 0.6, and so on. So this is an interesting problem, but we can't get it to give us a correct answer, or one that they will accept as a submission. So, Prof will rewrite problem exercise 3.4 and assign as homework. If you somehow miraculously get it to work on MindTap as well, then I want you to tell me and you'll get extra credit for that. I don't know how much time. You know what, if we Googled up, what if we cheat? I'm going to get you know, myself on academic probation here by cheating. I'm going to Google up, I'm not going to bother. I don't care. If you Google up a solution to this, I shouldn't say that, but if you Google up a solution to this that matches what they do, I'm really curious. Okay. And then 3.5 is a population one. The population one is not extraordinarily difficult once you understand something about what they're doing. But my previous training in writing population calculators did it in a completely different way than what they're asking. If you're talking about population growth, normally what you have is a growth index over a certain time, right? So every day my bacteria is going to get 10% more, right? So if I have 10 of them, or if I have 100 of them, then 10% more of that is, you know, 110. And then the next day it's going to be 10% more than that, so it's going to be 11 more than that, and 12, and so on. And so that's how something grows if there's no check on its growth, right? If nothing is dying or whatever. But instead, they're expressing the growth rate as an integer rather than as a percentage, and they're saying, and they're giving you multiple time units. It reaches this in 2 hours, but you're going to grow it for 6 hours. And that was the real hitch to getting it to work. Well, let's go and take a look at 3.5. Okay, so here's the problem, as described. A local biologist needs a program to predict population growth. We're going to ask for the initial number of organisms, the rate of growth, which is a real number greater than 1. If the number is equal to 1, it means it never increases in population. If the number is less than 1, it means it actually starts decreasing. But if it's greater than 1, like if it's 2, it doubles each time. The number of hours it takes to achieve this rate, right? It takes 10 hours for it to double. And then the number of hours during which the population grows, right? It takes 10 hours for it to grow that much, but we're going to track it over 20 hours. So what blew my mind here is trying to figure out fractional, right? If it takes 2 hours for it to double, but then you're going to track it for 3 hours. How do you get that to work? I never figured that one out. Maybe I should have just Googled up, you know, some answers, but I never got that to work. However, if you assume that they're going to be even multiples of each other, if it takes 3 hours for it to double, then they're going to ask for 3 or 6 or 9 or something like that. That actually gets you credit for it. So, for example, one might start with a population of 500, a growth rate of 2, and a growth period to achieve this rate for 6 hours. So it increases by 5 each time. Takes 2 hours for it to increase by 5, but we're going to track it for 6. So that means we're going to let it run for 3 times longer than necessary, or 3 times longer. So that's the key to getting this to work, is to divide the total length of time by the growth rate time. So write a program that takes these inputs and creates a prediction. So enter the initial growth number of organisms, 10. Enter the rate of growth, 2. So that means it doubles every 2 hours, but we're going to watch it go for 6 hours. So that means in 2 hours, it's going to double from 10 to 20. But we're letting it run to 6. In another 2 hours, it's going to go from 20 to 40, right? Because it's doubling each time. And we're, 2/3 of the way there. We've done 4 hours. And then one more time, we're going to do from 4 to 6. And so it's going to double again, and it gets 80. So this was the part that was really catching me, is the way that they were doing this. I was trying to, I don't know what I was trying to do, but it was not working. So why don't we do this one together too, if you feel like it? Sandbox could not load. Please refresh this page. Gladly. What, are you going to make me switch title to do it?
So would it be like input, A equals input?
Yeah, you're going to ask for 4 things. You're going to ask for the number of organisms, the rate of growth, the number of hours, and the total hours. And it looks like we may as well just make them all ints.
That's what I do.
Yeah, so again, I'm going to just copy and paste some of these things. And if you're typing this into idle rather than here, that's going to make it difficult for you to keep up. I'll pause it after a bit, and I'll always put it in the notes. So even if you don't get it working, that's okay. Alrighty. The initial number, I'm just going to call it pop for population, equals int parentheses input parentheses quote, and I just copy this message over here. I'm going to paste it. But I'm not going to put that 10 there. That's ridiculous, right? Get rid of that 10. All right, the next one. Enter the rate of growth. Again, I'm going to copy and paste. Everything but the 2. So I'm going to call that one rate. Rate equals int parentheses input parentheses double quotes. Enter the rate of growth, a real number greater than 0. In parentheses, in parentheses. I don't think there'd be anything wrong with making that a float so that they could say 2.5 or whatever, but all of their tests involve whole numbers. Enter the number of hours it takes to achieve that rate of growth. Good thing I have copy and paste. So hours equals int parentheses input parentheses double quote. Paste that message. And one more. Enter the total hours of growth. Going to copy that. Paste it here. Total underscore hours equals int parentheses input parentheses. I forgot my double quote, so that didn't quite work. Parentheses, double quote, paste, in double quote, in parentheses, in parentheses. All right, I'm going to make sure I don't have any syntax errors yet, so I'm just going to run it right now. Enter the initial number of organisms. 1, 2, 3, 4. Yeah, okay. I don't have any syntax errors. You may. Okay, so what are we going to do? We need to calculate the number of cycles, the number of times it's going to repeat. which is the total hours of growth divided by the number of hours it takes to achieve that rate of growth. So you could call it cycles or times or repeats or iterations. I'm going to call it cycles. You get the idea of a cycle, right? How long it's going to spin. Cycles equals total underscore hours. Spell it correctly. Total underscore hours divided by hours. But that needs to be turned into an integer for this to work. So I'm going to put I and T. Well, I guess I could put that on the next line. Cycles equals I and T parentheses cycles. And why do I have to turn it into an integer? Because I want to use a for range statement. And range doesn't work on floats. Only works on ints. So for, we just need a variable name. Doesn't matter what it is. I, good enough variable name. For I in range, parentheses cycles, in parentheses. Or if you feel like being real thorough, you can make it 0, comma, cycles, comma, 1. Right? Start counting at 0, go up to, but not including cycles. But this is enough. So range, parentheses, cycles, in parentheses, colon. We need to calculate the new population. Pop equals pop times rate. And if we felt like it, we could print some information out. Like what time it is, you know, what the value of I is, and then the current population. So why not? Print, or at least let's print out the population, just for fun. We'll go back and comment this out. Just to watch it grow. Didn't back tab all the way, and we need to print out this message the total population is. Without that 80 there, right? Because we're calculating that. And we want a blank line there. So I'm going to put an empty print there, or you could just do \n. Okay. So back tab that all the way. Print, parentheses, double quote, in parentheses, and then print, parentheses, double quote. The total population is, I'm going to take out that space and then do end quote, comma, pop. Like that. Now let's run it with their test data, see if it works. One of their tests is start 500, growth rate of 2, takes 6 hours, and then they run it for 12 hours. It should hit 2,000. That sound right? Yeah, maybe so. All right. Let's run it. Initial number of organisms, 500, not 599. 2, because it doubles. It takes 6 hours for it to double, but we're going to run it for 12. And the total population is 2,000. That's what they wanted. They give us another example down here of starting at 10 hours, doubling every 2 hours, and running for 6. So I'm going to rerun the program. 10 organisms, growth rate of 2. Takes 2 hours to get that large. We're going to run for 6. All right. So it seems to be working, so I'm going to delete or comment out that print statement. And then I'm going to run the test. So I'm going to go over here to tasks, do run checks. I hope I got it. You know, this looks pretty simple once you see it, but those of y'all who've worked on it will back me up. It wasn't as easy as this makes it look. So anyways, okay, so that does seem to be a valid solution. I'm going to take this, copy and paste it into my notes as well. Just for those of y'all working at home. Alrighty. Let's see how y'all are doing with it. All right, so I'm going to go through and judiciously remove maybe a great many of the other programming exercises, and like I said, I'll offer you extra credit if you do them. All right, I'd like to get back to the lecture. All right, so we've talked about we've talked about or, and not. For and to trigger, both of them have to be true. So if A is set to true but B is set to false, then is A and B true or false? It's false because they would both have to be true. Just like in order to stay home, you have to be both sick and tired. Well, if you're not sick, you don't get to stay home. And if you're not tired, you don't get to stay home. So they both would have to be true. Or, a little bit more lenient, one or the other one could be true for the result to be true. We get to stay home if we are sick or tired. So if A is true, but B is not, that's okay. It's still true. And then lastly, not just reverses it. So if A is true, then not A is false. And in this case, if it was not B, well, what is B? B is false, so what is not B?
True.
Yep, it's true. So the order of precedence, not has the highest precedence, and has a middling precedence, and or has the lowest precedence. Because and is akin to multiplication, I think I demonstrated that to y'all, and or is akin to addition.
And is akin to multiplication?
Maybe I better go over that again. I wasn't absolutely sure I'd cover that, so I'm glad you asked. Yeah, you would think. So if you have, we're going to treat 0 as false. Excuse me. We're going to treat 1 as true. And then if we have and x and y and the result, well, you could have false and false. You could have false and true. You could have true and false, or you could have true and true. And for and, what's the only time that they are true? When they're both true. So this is the only time you get a result of 1. Now let's do or. You don't have to be typing all these. X or y, and the result. Same thing. False or false. False or true. True or false. True or true. When's the only time that or is false? 0 and 0, because all the other ones are going to be true, because it's one side or the other has to be true. So if you look at this and substituted an asterisk for multiplication, 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. The only time we get a 1 here is 1 times 1. So and can be thought of as logical multiplication. If you ever take a logic course, like at a 4-year school or something, then you'll use multiplication symbols in order to indicate and. There are other symbols as well, but like if you have A or B, then you can express that as A plus B. And if you have A and B, you can express that as just AB. Now let's go back to our OR. 0 plus 0 is 0, that's true. 0 plus 1 is 1. 1 plus 0 is 1, and 1 plus 1, well, we are in a world where we only have 2 possible values, 0 or non-zero. So anyways, that means that OR is logical addition. Does that make sense? You with me on that one? You in agreement? Okay.
I want to.
So if you had this expression, just logically, A or B and C or D, then by those terms you could say A plus B times C plus D. And it'd be real easy to figure out which ones happen first. Multiplication always happens before addition, so it would be treated just as though that were the case. Wait, that was the case. So the B and C gets done first. Precedence, hierarchy, not, followed by and, followed by or. So if you had, I'm just going to make one up, I don't even care, A or B and C or not D and not and E, then the very first thing you have to do is that one. Or when I say you have to do, the first thing the computer does when it's calculating that expression is take D and flip it. If it was false, it takes it to true, or vice versa. So not D happens first.
You mind rolling back to the first part real quick?
How far up? I know what you're going to do. You're going to fax that to another professor and get her to prove me wrong. Don't do that. No, I'm kidding. Always free to correct me or challenge me. I appreciate it.
No,
Sure.
I remember in last semester, I think you covered that, and I never quite got it.
Yeah.
I think I got it wrong on the
Oh, okay. But it's making more sense now?
Yeah.
Cool deal. So short circuit evaluation. And is like nested ifs. What do I mean by that? Well, we may as well actually type it into idle. We may not have any much stuff to type into idle. We may just have a little field for you to type in that you were here. Anyways, so sick equals capital Y because I am sick. Tired equals capital Y because I am tired. If sick equals Y, colon, if tired equals Y, colon, then print, you are sick and tired. Stay home. End quote in parentheses. That's a nested if. So and can be thought of as a nested if. Why do I say that? Because we could rewrite it like this. If sick equals quote Y, and tired equals quote Y, print, yep, stay home. Like that.
Put an else in there?
I could throw some else's in, but for this example, I'm not gonna. So, I mean, the way it's wired is it's going to print "you are sick and tired," no matter what. And you're right. The problem the problem with doing it as a nested if is that it's not easy to throw an else in there, right? Whereas it is easy to throw a nested if, put an else in here. You're absolutely right. Because if I wanted to put else's on this one, don't do this, gang, but I'd have to put an else here, and I'd have to put an else here, right? And that'd be a real drag. But it'd be real easy to put an else just one time. So, nested ifs, as opposed to using the AND operator, AND is a bit better. Unless you have some reason to do it otherwise. But this kind of implies something about efficiency's sake. If this is not true, does it ever do this check? What if sick is not equal to y? It never does that check. And you can use that to increase the speed of your program. Now, Python is not the world's fastest programming language, and you're usually not trying to optimize it as much as you would if you're doing C++ programming. But if this is not true, it doesn't do this one. Same here. If this is not true, the compiler is smart enough to decide not to do that part. Looks like I have some uppercase and lowercase y issues. I should have made them all uppercase. So if this is not true, it skips doing that. That's called short-circuiting. And it's not bad. Short-circuiting sounds bad. You know your house is burned down if you get a short circuit. Well, not here. So short-circuiting, if the first part of an AND expression, slow down. If the first part of an AND expression is false, I'm going to capitalize false because that's how Python likes it, then the second part is skipped. So if you were going to have a loop that repeated a check a million times, over and over and over, and you wanted it to run as fast as possible, you would want to rule out, because it either has to do one check or two checks, right? It only does one check if this is false. But if this is true, it's also got to do the second check. And so you can take advantage of short-circuiting by saying, I'm going to put the test that is false most often first. Because if I can rule it out early, then the computer doesn't even have to do the second check. And remember, each check, is a logical statement that takes, a finite amount of time. Yeah, it goes pretty fast. But if you're trying to write something that's going to calculate pi to 8 billion digits or crack, some incredibly complex, cipher or something like that, and you're trying to write really efficient code, then you'd want to put the check that is false most often first. So I'm going to put that as a comment. To take advantage of short-circuiting, put the condition that is false the most often first. So if it turned out that this check, tired, we're sick a whole lot more than we are tired for some reason, then we'd want to put that first. But as is, we're tired a lot, but we're only sick a little bit. So I don't mind leaving it like this, right? Because this one's going to be false more often. Now, OR has the opposite rules. For OR, if the first part is true, it skips the second one. So, when am I going to eat? I'm going to eat when I'm either bored or hungry. That's the way my dog is. Hungry is equal to true. Bored equals false, capital F. And if hungry or bored, colon, parentheses, time to eat. Since it's OR, only one side has to be true. They both don't have to be true. That means that if this one is true, it can skip that one, and it does. The runtime engine goes, oh, that part's good? Nah, don't even bother doing that one. So for short circuiting, if the first part of an OR is true, the second part is skipped. If the first part of a double quote or double quote so if the first part of an OR is true, comma, the second part is skipped. So to optimize, you put the condition that is true the most often first. To take advantage of short circuiting, put the condition that is true the most often first. But like I said, at Python, doesn't run fast enough that you're seriously going to take this into account, but not all of y'all are going to be programming and only in Python all your lives. I'm going to run it, make sure I don't have any syntax errors. We're not asking for input, so it's not a lot of different ways I could test it, right? Right, you're sick and tired, stay home, time to eat. So, I am hungry more often than I'm bored, so this is the right way to do it. Maybe not. Maybe I'm bored more often than I'm hungry. If that was the case, I would reverse those. So when you're testing, you want to test to make sure all possible branches are executed. If there's an if and then there's an else, make sure that they both work, right? When we were testing our right triangle evaluator, we would want to test to make sure it can say that yes, it's a right triangle, or no, that it's not. If you've only tested it one way, then you haven't tested it completely. So a while loop can be used to describe conditional iteration. A program's input loop that accepts values until user enters a sentinel. A sentinel is just a value that stops the input. So we're going to write a program that asks the user to enter stuff, but as soon as they enter a specific value, we're going to stop. So I'm going to go back to my code. Let's make a list of favorite foods. Nah, let's just do numbers. Numbers are easier. So scores is equal to 0. And then we're going to ask them to enter a score. So I equals int parentheses input parentheses quote enter score or -1 to quit. End quote in parentheses. In parentheses. While I is not equal, whoops, I did that wrong. Yeah, no, that would work. While I not equal to -1, colon, we're going to add that to our total. You know what, I don't like the variable names I chose. I'm going to change them. Total equals 0. Score equals int, and while score not equal to -1, then we're going to add that to our total. Total plus equals score. And we should keep a counter of how many scores have been entered as well. So I'm going to make another variable that'll keep track of that, right? Num underscore scores equals 0. And after we add that score to the total, then we're going to add 1 to number of scores. Num underscore scores plus equals 1. But then we have to ask that question again. Easiest way would just be to copy and paste. Take this statement, copy and paste it, and indent it so that it's tucked inside the while loop. Copy that line. Come here. Paste it. Indent it. Now we're good to go. So that's a while loop. It's going to keep going as long as they don't type in a -1. As long as this condition is true, it's going to keep repeating. But if score ever becomes -1, then this will no longer be true, and it's going to fall out of the loop. That's the way a while loop works. So let's calculate the average while we're at it. AVG equals total divided by num underscore scores, and then print parentheses, quote, total equals, end quote, comma, total, in parentheses, and do the same for average. Print parentheses, quote, average equals, end quote, comma, average. No, AVG, in parentheses. I'm going to go ahead and run it and make sure I don't have any syntax errors. Enter the first side. All right, 1, 2, 3. Enter a score. 10, 20, 30, 40, 50, 40, 40, 40, 40, -1. So the total was 310 and the average was 34.4. There is a problem with our algorithm here, which is what happens if they don't enter any test scores at all. If we type in a -1 right from the get-go, then the total is 0 and the number of scores is 0, and 0 divided by 0 equals a great big error. So that's not good programming. We should have an if statement in there. But I'm not going to even fix that. I'm just going to add a comment. Note, if the user enters no scores, we crash at the divide by 0. All right, I think that's about enough, about far enough to do what I want to do next. Is I'm going to give us a couple of little homework problems, very short little logic problems that use and or. Let's see if I can remember them. Let's do one called monkey trouble. You have 2 monkeys. It's bad news if both monkeys are smiling, they're up to no good. It's also bad news if neither monkey is smiling, because they're angry. But if one is smiling and one's not, it's no problem. So ask the user if monkey 1 is smiling, y/n. Ask the user if monkey 2 is smiling, y/n. If both monkeys are smiling, or if neither monkey is smiling, we are in trouble. So print monkey trouble. Otherwise, print no problem. All right. We also have a parrot in our house, and the parrot's incredibly loud. Our neighbors hate us. So, parrot problem. Ask the user if the parrot is screeching, y/n. Ask the user what the hour is, an int between 0 and to 23. The rules: if it's too early in the morning and the parrot is screeching, our neighbor hates us and we have a parrot problem. Or if it's too late in the evening. So, if the parrot is screeching and it is either before 7 or after 20, the hour, then we have a problem. So print parrot problem. Else print no problem. I think I'm going to go back and make this say no trouble to make it match the other one. All right, one more. It's awfully hard for us to remember if we have to get up early or not. We have to get up early if it's either a weekday, but if we're on vacation, we don't. So, wake up call. We're going to ask the user if it's a weekday, YN. Ask the user if we are on vacation, YN. If we are on vacation, or if it is not a weekday, then we can sleep in. So print sleep in, exclamation mark. Else, comma, print wake up. Makes sense. 3 little logic problems just involving and or. There's more than one possible solution. So, like this one could probably be expressed in a single if statement with no ands and ors at all. And if you can figure out how to do that, that's cool. If you have to use ands and ors to get it to work, go for it. Make sense, gang? All right, I'm going to print this out because we had some instructions here and I left some of y'all behind. Who needs a copy of the instructions if they want to finish typing in stuff? 1, 2, 3, just 3, 4. Oh, you're going to make me hit print each time. Thanks. Alrighty, I don't think I had a Dropbox ready, so if you're having to leave now, remember you need to upload something to that Dropbox when you come back.